Nap time's over.
In this video, I'm going to be talking about the multiple effects on the immune system of mushrooms. I'll also be talking about some different types of mushrooms as well. Okay, so mushrooms have beta-glucans, and they have rather extreme effects, but rather profound and very important and even altering effects on the immune system. Now, what ends up happening with the immune system and what the mushrooms do is that they actually alter the immunity so that it's trained immunity. And the beta-glucans, they induce this trained immunity state, causing a long-lasting, non-antigen specific reprogramming of innate immune cells. And it's rather different as compared to not having mushrooms, because there's basically no off switch to the immune system. This is why you have to be careful with mushrooms, because it could even lead to autoimmunity. But in this trained state, it does come with a functional outcome that is rather beneficial, is that enhanced or upregulated phagocytosis, also higher reactive oxygen species. So that could be an issue. That's why mushrooms could be lethal. Enhanced antigen presentation, that's important to train the T cells. Also, antigen presentation is also important for the ICAM, also for the T cells to receptors to cluster and to attach onto the pSMAC, but that's for a different video. Also, increased cytokine burst upon tumor sensing. So that's like a cytokine attack when they see the tumor. Also increased cytotoxicity, so like to attack cancer. And then upregulated T cell recruitment and priming, which is why there's the risk of autoimmunity, because T cells attack a healthy bodily tissue, which is what autoimmunity is. Okay, so this trained immunity state is a basically heightened readiness state. So there's also an increase in glycolysis and cholesterol synthesis. So immune cells and T cells need glycolysis, but tumors can also hijack glycolysis and use glycolysis. Now, beta-glucans from mushrooms have this interesting effect and interaction with cholesterol handling, is that they are internalized, the beta-glucans, via dectin-1, via clathrin-dependent endocytosis. Endocytosis needs CD14 on the toll-like receptor 4 to work, and with the CD14, it can be cleaved off, which possibly means reduced endocytosis. So beta-glucans, they traffic to lysosomes where they alter lysosomal pH. They also engage with these trafficking transporters called NPC1 and NPC2. That's critical to redistribute cholesterol, because the lysosome can become dysfunctional if there is too much cholesterol in the lysosome. Therefore, the lysosome cannot degrade exosomes, and then the tumors get the exosomes, which is not a good situation. Okay, another thing that beta-glucans in mushrooms do is that by depleting or redistributing cholesterol, that could actually affect the clustering of receptors due to reduced receptor density per cluster. Now, this means less sustained clustering. That could have an issue with T cells, because T cells, they need to be able to cluster their receptors. And also, so this could also alter how the T cells interact with the pSMAC, because receptor clustering is also required when T cells interact with the pSMAC. Beta-glucans, they can also cause machinery to break down. That could be good against cancer, because cancer uses machinery for certain cancer processes. That's also kind of good and bad with the immune system, because the immune system needs machinery as well. But I think the reason mushrooms break down this machinery is to prevent autoimmunity, because if the machinery is too strong, or if the immune system is overactive, that could cause overactive T cells and to attack the healthy bodily tissue with those T cells. The good thing about mushrooms is that the way it affects the tumor cell side, so by reducing actin polymerization, or in actin integrin clustering, or beta-glucans in mushrooms, weakens actin anchoring. Now, the reason that actually is a bad thing for the tumor is that the tumor needs actin polymerization in order for CD47 inhibitory to work. So a tumor uses CD47 uh, to interact with the eat me signal on the immune cell, disabling the immune cell, which is SIRPA. So mushrooms disables the CD47 SIRPA axis, so that the tumors can't disable the macrophages. Now, up next is a different kind of mushroom called cordyceps, and it has cordycepin, and it has been studied for anti-tumor and immunomodulatory effects. And one of the relevant effects is, as I said earlier, CD47 SIRP alpha. It helps, cordycepin helps macrophages escape or avoid the don't eat me signal on the tumor, which is the CD47. So if cordyceps reduces the CD47 expression on some cancer cells, that means that it enhances macrophage phagocytosis of tumor cells, uh, because the CD47 on the tumor is not sending the don't eat me signal to the macrophage. So that's what cordycepin does. It allows the macrophage to engulf the cancer or tumor cell. Okay, another thing that mushrooms do is that there is less raft stability. This can be a good thing to reduce CD70 expression on tumors, so that they don't do the axis, CD27, CD70 axis, and then NFKB, and then lost exhausted T cells. Also, another good thing about no lipid rafts is that the APCs, or antigen presenting cells, the ICAM1 is disabled because of mushrooms. That way, they can't train the T cells. So I think mushrooms is doing this as a way to reduce T cell numbers, to reduce the risks of autoimmunity. Because if APCs don't have the ICAM1, then they can't really create the CD70 that will also end up interacting with the CD27 on the immune cell. So that's it for the video. Like, comment, share, subscribe. Keep it locked in here on this channel, and I'll see you in the next video.